So what is divergence? First of all, we have to look at this thing. Suppose you are given a vector f defined by the components f1, f2, f3. So that means you have f1 I cap, f2 j cap and f3 k cap. Then the divergence of this function is defined by del dot f, right? Gradient was simply del of f vector, not vector but scalar quantity. So here this f in gradient used to be scalar, and whatever is the result, that is a vector. But here in the case of divergence, we have del dot f. So here this f is a vector f and your answer, that is a scalar quantity, right? And how do you define the dot product of two vectors? Because what is the definition for this del? You know, it is del by del x I cap plus del by del y j cap plus del by del z k cap dot with vector f, and vector f is f1 I cap plus f2 j cap plus f3 k cap. So that means when you take the dot product, you multiply I with I term, right? So you have del by del x of f1 plus del by del y of f2 and del by del z of f3. So this is your divergence of the function of the vector f. Now here, that as I've told you, divergence is always applied onto some vector, and as a result we obtain a scalar point function. For an example, for the problem, suppose this vector f is given to us, x y square I cap plus 2x square yz j cap minus 3yz square k cap, right? We have to determine the divergence of this function, this vector f. So that would be del dot f vector. So that would be del by del x I cap plus del by del y j cap plus del by del z k cap. So this is the definition for del dot with the given vector. So that is x y square I cap plus 2x square y z j cap plus minus 3 y z square k cap, right? So how do you take the dot product? You apply this thing onto this thing, so that would be del by del x of x y square plus then you apply this thing onto this thing. So that means you have del by del y of 2x square yz, and thirdly you will apply this operator onto this particular function with a negative sign, right? So del by del z of minus 3yz square. So now it is very simple to take this partial derivatives. So it would be, here y would be treated as constant, so it would be y square, and then when you take the partial derivative of this with respect to y, x and z would be constant, so it would be 2x square z, and lastly when you take the partial derivative of this thing with respect to z, y would be treated as constant, so it would be minus 6yz. So this is the divergence of the given vector f, and note that this is a scalar quantity. It does not involve any direction, any unit vectors I cap, j cap or k cap. The next question we are to determine the constant a such that divergence of this vector f is equal to 0 here. So this is the given vector and we are to calculate the divergence. So we are given del dot f vector is equal to 0. Right? And here you do not write arrow. Why? Because the 0 is a scalar quantity here. So it would be del by del x I cap plus del by del y j cap plus del by del z k cap dot product with the vector f, which is x plus 3y I cap plus y minus 2z j cap plus x plus az k cap. So this is given to be 0. Now you have to calculate the divergence here. So it would be del by del x, x plus 3y plus del by del y, y minus 2z, and then you have del by del z, x plus az, that is equal to 0. So when you take the partial derivative, it becomes 1 plus 1 plus a. this is equal to 0. So from here you obtain the value of A as -2. So this is how you calculate the divergences of different curves, right?